The last few episodes, we kept talking about storage. How to shard the database, where to put the cache, where to read the data from. It's all about storing. Today, a different topic. How services talk to each other, how they work together. Let me give you a real scenario. A traffic spike, a flash sale, a trending post, a wave of requests all slamming in within the same second. Your server gets crushed on the spot. Why does it crash? Because you make every request stand there and wait until it's fully processed, start to finish. Today, I'll actually run it for you. Put a queue in the middle and watch crush turn into holds up. Let me weld one sentence into your head first. Async means decoupling in time. What's synchronous? I call you, and I just stand there, waiting for you to finish. You're slow. I'm slow with you. You go down. I go down with you. That's coupling. Async is this. I toss the work into a queue and turn and walk away. You come back and grab it at your own pace. Here's an analogy. The restaurant front desk takes orders, the kitchen cooks. Does the front desk wait for one table's whole meal to come out before taking the next order? No. That order rail in the middle, that's the queue.
Remember 3 roles: producer, queue, consumer. This whole episode, it's just this one diagram.
First, let's see what happens with no queue. 200 requests burst in, almost all at once. Each one takes 20 milliseconds to process. I make the front door take one, handle it on the spot, one at a time, in line. The client? It waits past 1 second, then gives up.
The result: only 50 served, 150 dropped. The last batch in line waited almost a full second for their turn. Tail latency, 980 milliseconds.
The front door got completely jammed by this wave. Note, this isn't the machine being weak. It's the wrong approach. Now let's change just one thing. The front door stops doing the work itself. It just drops the request into the queue and immediately replies, "Got it." Behind it, I put 4 workers, consuming in the background at their own pace.
200, all accepted, 0 dropped. The front door does just one thing each time. In queue, 4 microseconds. The user gets accepted instantly. That peak wave, 4 workers, 1.2 seconds, drained.
This is peak shaving, absorbing the spike. Listen closely to this one. A queue doesn't make processing faster. It decouples receiving from processing. The spike hits, the queue catches it first. The work gets spread out over the time after, done slowly.
One more thing, there are 2 kinds of queues. One is the message queue. It takes messages, stores them, forwards them, like Redis, RabbitMQ, Amazon SQS. The other is the task queue. It takes the data and the work together, runs it, and hands you the result, like Celery.
The names don't matter. What matters is that diagram. Producer, queue, consumer. But the moment you drop in a queue, 3 new headaches follow. The first one. A queue is not a free warehouse. I make the producer 5 times faster than the consumer and pour in 5,000 messages.
Unbounded queue. The backlog climbs all the way to 3,900, and it's still going up. Memory blows up sooner or later, OLM. The queue just hid the overload. It didn't solve it.
Switch to a bounded queue, cap of 100.
When it's full, it just returns a 503 and sheds load early. The backlog never goes over 100.
Full is a signal, not a warehouse. Either reject fast or block the producer. Let the pain travel back to the source. Don't let it pile up silently in the middle. This push-back move, that's back pressure. The second headache. Messages get duplicated. Most queues only guarantee at least once. The network hiccups, the ACK gets lost, and it redelivers.
100 charge messages actually delivered 124 times. 24 of them are duplicates. If the consumer blindly charges on every delivery, it charges $1,240 total. $240 overcharged.
Sit with that for a second. That retry that saved you from losing an order now bites you back.
Add one thing. Deduplicate by message id, skip anything already charged. Exactly $1,000, not a cent more.
Burn this line into your memory. Exactly once in engineering equals this. At least once delivery, plus an idempotent consumer.
Zoom out one more level to communication. How services talk to each other, just two styles. Synchronous, like a phone call. RPC, rest, I ask, you answer, and I have to wait. Asynchronous, like sending a message. Send it and go, check back later. TCP and UDP are the transport layer version of the same thing. TCP handshakes and retransmits, guaranteeing you receive it. UDP fires and forgets, just going for speed.
Video and games. Why do they use UDP? Because a frame that arrives late is worse than one that's simply dropped. So AI shows up. Which part of this does it touch? The most direct place it helps. A large model spits out one token at a time. It's a stream by nature. Let me run it for you. Generate 40 tokens, 50 milliseconds each.
Blocking. It waits for the whole answer to finish, then returns. The user stares at a blank screen for over 2 seconds, not a single word. Streaming, SSE, every token that pops out gets pushed. The first token lands in 51 milliseconds, 43 times faster.
The total time is exactly the same, but you're already reading. Look at this structure. The generator is the producer, your screen is the consumer, and that SSE stream in the middle is the queue. Today's diagram copied straight onto AI.
Run the 4 questions. What does it help with? Streaming cuts time to first token from seconds down to tens of milliseconds. Inference, embeddings, batch jobs, all a natural fit to toss into a task queue and run async. What does it replace? Swap synchronously waiting on a slow model for queue it up, plus stream the results back. Long jobs like running an agent or generating video fan out from one producer to a bunch of workers. What does it change? Back pressure becomes a first-class citizen. Tokens generated faster than consumed. GPU queues backing up. It's all the same bounded queue plus back pressure problem.
So what can it change? Let me be honest. AI can't change the physics of async. The fact that exactly once is fundamentally hard, it can't help with that. The idempotency key, you still have to design that yourself. Streaming is an experience optimization, not a throughput optimization. It saves you 0 total compute. Before we wrap, a few traps only people who've been burned really get. 1. A queue masks overload. It doesn't solve overload. If you don't wire up back pressure, don't watch the backlog. It'll roll the snowball all the way to OM for you. 2. Forget idempotency, and you get double charges, double text messages. In an at least once world, idempotency isn't optional. 3. Async is hard to debug. One path gets split into several segments, and when something breaks, you lean on tracing to piece it back together, segment by segment. 4. Not everything should be async. Anything that needs an immediate result or strong consistency. The payment success page. Just go synchronous, honestly. 5. Exactly once is a marketing phrase. What actually lands in your hands is at least once, plus idempotency. Let me weld one last sentence to close. Async trades an immediate, certain result for throughput and resilience. Another trade-off. By this point in the course, have you noticed, from start to finish, it's all trade-offs. Whether to go async, just ask yourself 3 things. Can you decouple in time? What happens when the queue fills up? What happens when a duplicate shows up? At this point, the fundamentals of system design. Orders of magnitude, scaling, consistency, caching, sharding, async. The whole 9-piece set is complete. Next, we stop taking apart one component at a time. We start taking these components and, for real, assembling them into a complete system. That's where this course really gets fun. See you.